Okay, that's good. Good. All right. Okay, so for the first one, it's being increased, it's increasing. The student population increased by 44 students per year. Well, that should tell you right away, even though on the next slide I kind of show it, but that should tell you right away that N of t in this case is going to be linear. This is linear, and how do I know that? Well, because the function is changing value by a fixed amount. You know, it's not like in D where there's a percentage. Good. Okay, well, I did put some calculations in here just to help people see what's going on. Okay, so at time 0, right? That's 1996. N of t, you know, the initial value, right, is 440. 1 year later, at time 1, what's going to happen? Well, in A, which is what we're in now, the function value, the enrollment, is increasing by 44. So the number of students enrolled now is 440 plus 44, which is 484. What about another year later, to 2? There, right, it's going to be 484, how much from the previous year, right? But we're adding 44. So again, every year goes by, 44 more students attend school. So another year goes by from 1 to 2, we're adding 44 to our N of t. 44 more students are enrolled. But if you think about the calculation, what's really happening here? We have 440 plus 44, right? That's our 484 here. Right? Yeah, let me actually get the pen out. That might help. Like so, right? That's our 484. So let me do it like this. Good. And then we're adding 44. So altogether, we have 440 plus 44 times 2. So we have 440 plus 44 times 2. And that really should make sense, right? This is what there we go. This is what we start with, the 440. But then 2 years go by, and each year we're adding 44. And then, of course, we have a third year, right? It's really just the same calculation. This is all equal to 528. But if another year goes by, we're adding 44 students. 44 students, okay? So we have 528 plus 44 now. But again, using this calculation, 528 is 440 plus 44 times 2. Okay? Right, that was the line above. But again, we're adding 44 more students. So altogether, we're going to have this amount. Right? Kind of like above, the 528 is going to become this. Then we're adding 44. And so we get this. And really, that should make sense, right? This is our starting amount, the 440, right? 3 years have gone by, and each time we're adding, and each year, 44 students are added. So this calculation should make sense. You know, look at what the calculation is telling you. And this is 572, yeah. But again, note what I'm trying to show you here is, in each case, we're increasing the function, the amount, by 44, by a fixed amount. So this is linear. Although even before we did the calculations, we should have seen that. And the slope, the rate of change, is 44, right? Because the output is increasing by 44%. 4 students per year. So we have M is 44. And the initial value is 440. So a formula for NFT is this. I mean, I threw those calculations in there just to illustrate and help people see that, yeah, this is a linear function. So that's what we get here. Okay, cool. All right. For part B, the number of students instead, the student population, it's decreasing by 32 students per year. Well, again, that's going to be linear, right? Because it's changing by a fixed amount. But notice since it's decreasing by 32, well, it's very similar to A, except now the slope is not going to be 44. It's going to be negative 32. Again, it's decreasing by 32 students per year. So our slope is negative 32. The initial value is still the same. So we have m times t plus b, negative 32 times t plus 440. For C, it's remained constant, right? You know, it's constant. Well, if it's constant, that means we're not adding any more the enrollment, the student population, that is not increasing by any amount. It's not decreasing by any amount. If it's remaining constant, you know, it's not changing. So that forces the slope to be 0, the rate of change, because the output is not changing. So in this case, we had N of t looks like this, which is 440. And that should make sense, right? Because 440 students we know were enrolled, but if no students are being added or leaving school, that is, or if there are no students, how do I say it? There's no students being added or removed from the student population, well, yeah, N of t is going to have to stay 440 no matter what. So yeah, the slope should be 0. Okay, you know, I'm trying to get you to see that, yeah, the calculations in the context of the problem, they do make sense. They're saying what we expect. All right. And D, of course, you know, D actually should be pretty straightforward. If it's increasing by a percent, a constant percent, then it's exponential growth. So in this case, our N of t, it has exponential growth. Well, it's 2.5%, so R is 0.025. The initial value is 440. So again, using our function, we get this thing. 440 times 1 plus 0.025 to the t, like so. Which you can write this way. All right, that was good. Do you have any questions about that? All right, let me do it this way then. Okay, I set the poll out, so, you know, again, be honest. Don't be afraid to be honest. But if it does make sense, say so. So I want to make sure everyone understands it. That's my goal. Yeah. I mean, that's why I threw the calculations in. I was just really concerned that, you know, when I said, oh, it's linear, but I felt like I wasn't really showing why. The calculations illustrate why the function is linear. So, you know, it's good to do calculations when you're working on a word problem, because again, that can help you understand what's going on, you know, what's happening. So looks like everyone is saying yes, at least most people. So, all right. All right, so with that said, let's do some more word problems. These are going to be more in percents now. Okay. All right, good. All right, here. So now we're in word problem example 3. Okay, we're not at percents yet, sorry. So here, it's the year in the year 1987, right? You have an investment that's worth this amount. Now, in the year 1997, the investment was worth this amount. Now, we want to know find the rate of change of this investment. So here it's nice because I tell you that the investment is growing linearly. Well, the rate of change then is nothing more than slope. Change in output over change in input. Right? It's going from 1987 to 1997. And during that time span, it starts at 26,200, ends at 43,800. So what's the rate of change? Change in output over corresponding change in input. Change in output over corresponding change in input. And input is time, so we have the change in input and change in output, change in investment value. So we have this. Which is the same as saying $1,760 per year. Notice the units here, right? The numerator is dollars. The denominator is in time, in years actually.